10.1 Areas of Parallelograms and Triangles. The objective in this lesson is to find the area of parallelograms and triangles. Our first theorem here is the area of a rectangle, and it says the area of a rectangle is the product of the base and the height. So we know from previous lessons that area is base times height, and we also know that height is always measured perpendicular. So in our rectangle here, it's very easy. We have right angles, so we have two sides that are perpendicular to each other. We label one the base, one the height, put it in our formula, and we can find area. Our next theorem here is the area of a parallelogram. Now, a parallelogram is very similar to a rectangle. It's just kind of a tilty rectangle. The area of a parallelogram is also the product of the base times the height. And I told you a long time ago when we started these that area is always base times height. And we'll see more of that. So in our parallelogram here, we choose a side, that's the base, and this time we measure the height from a vertex perpendicular to the base. This time the height is not one of the sides because we don't have right angles. Now, sometimes, like we did if you remember back with our triangles, we might have to extend the line that contains the side and drop down a height from there. So we've done this before. A little bit of vocabulary here for us. The base of the parallelogram can be any one of its sides. The corresponding altitude is the segment that is perpendicular to the line containing that base. So altitude is simply our height. And so you see we have a nice parallelogram here with a base, and then, so if our base is here, then we draw in our height here, perpendicular to the base. Now what if our known values are not on the bottom? Well, it doesn't matter. That's still the base. We extend the side, go from the vertex of the opposite side and perpendicular to that line. And guess what? If you turn your paper, that base can be on the bottom. And we measure perpendicular from the other side, perpendicular. So in our examples here, we want to find the area of each parallelogram. And so I go, okay, well, here's my base, and here is the distance perpendicular to that, so that's going to be my height. And I highly, highly, highly recommend labeling all of your parts. That's how we do math. Draw the diagram, label what you know, write your formula, substitute in. So we substitute in, and we get 5 times 4 is 20, and area is inches squared. Area is always units squared. In the second one here, we have some measurements. Now, who's perpendicular to who? Well, this is going to be our base, and because this is perpendicular to the line that contains that base, it's going to be our height. Now, could we have used the other side as a base? Yes, but we don't have the height that's perpendicular to that. So we substitute those into our formula, and we get the area is 2 times 3.5 is 7 centimeters squared. And yes, I will count you off if you don't label with proper units. Now, the next example here, this is a good example. You're going to say, I don't know how to do these problems. I'm going to say, you do, because you have a good example. We want to find this length right here. And it says to the nearest tenth. So we want that length. Well, that length is perpendicular to this side. So this is my base, and this is my height. But I don't have that number. But what's really handy is I do have this length right here, and this, which is perpendicular to it. So guess what? I have a base and a height. So I take my known values and I find the area of my figure, and I know that area is 117 inches squared. Now, no matter where I measure base and height on this figure, the area is always going to be the same. The area that this figure takes up is never going to change. So if I now know my area, I substitute it in and use my base and find my missing height. And then just algebra. And so the height is about 12.4 inches. So I can use what I know to find a value that lets me find what I don't know. I use two sides that I do know to find an area. I substitute my area into my second equation. And it is time for you to pause the video and do the next couple of problems. The first problem was straightforward, very simple. Area of a parallelogram with base of 12 meters and height of 9 meters. So this is just area's base times height. We got an area of 108 meters squared. The second problem was a little more challenging. It was just like the example we just looked at. Parallelogram has sides of 15 centimeters and 18 centimeters. That's easy enough. The height corresponding to the 15 centimeter base is 9 centimeters. So I drew in my 9 centimeter height. It's perpendicular to my 15 centimeter base. We wanted to find the height corresponding to the 18 centimeter base, which I drew in, just drew a line perpendicular to the 18 centimeter side. So I knew that I can find my area based on the two known values, was 135 centimeters squared, and just simply substitute that in to my equation and for the area of base times height and find my unknown height. So the height for the 18 centimeter base is 7.5 centimeters. Those are easy if you're careful. Label, write your formulas, do your substitution. All right, now on to triangles. Now we know that a triangle is half a square, or half a parallelogram, half a rectangle. What this says is you can rotate a triangle about the midpoint of a side, so we're talking about right there, and we just flip it around, and what do we get? We get just like that. Right? There's our other triangle. And so all this is saying is that the area of a triangle is 1/2 base times height, because it is simply 1/2 of a square. Height, again, is still measured perpendicular to that base. Told you, all these things are base times height. Now, the base of a triangle can be any of its sides. The corresponding height is the altitude to the line containing that base. And you know that in a right triangle, we did this before when we did triangles, that the base and the height are already designed right there for us. And in really tilty triangles, you have your base, and we have to extend that side out to get the height. So you know how to do this. Next example talks about how many square feet of material do we need to make a sail. But look at our units here. We've got 12 feet 2 inches is our height. I see my perpendicular right there. And 13 feet 4 inches is my base. That does not look like something that is going to be easy to deal with. So the first thing we're going to do is convert our dimensions to inches. And how do we do that? Well, we turn the feet into inches and then add the inches onto it. So our height ends up being 146 inches, and our base ends up being 160 inches. And then it's just 1/2 base times height. We do the math, and what do we get? We get 11,680 inches squared, but we were asked to find how many square feet. You have to be careful when you're converting area, because how do you make area? You take inches times inches. So when we do a conversion, we take our inches squared and we do our conversion. We divide by 12 to turn one of the feet into, or one of the inches into feet, and then we divide by 12 again to turn the other inches into feet, because this is inches times inches, right? That's how you get inches squared. So we have to turn both of those inches back into feet. And then we will have feet times feet on top here and get feet squared. So be careful when you're converting inches. And now it looks as though it's your turn. Pause the video, do the next problem. This problem was really pretty easy. We have a right triangle, so our base and height are given to us. So the base is 1 foot. I changed that to 12 inches because my height is 5 inches, and inches seemed easier to deal with. And area equals 1/2 base times height for a triangle. So the area of my triangle is 30 inches squared. Now we weren't told what units we wanted this in. We could have changed it to feet squared if we wanted to. I just divided by 12 to get rid of one of the inches and divided by 12 to get rid of the other inches. And I would have gotten 0.21 feet squared. So it's good to be able to know how to do that. And our last example here, we've done these before. These are composite figures or irregular figures. And what do you see here? I see a triangle and I see a square. So square, we know that this is 6 inches, this is 6 inches, and for my triangle, I know that this is 6 inches as well. So for the triangle, I've got base equals 6 inches, height equals 8 inches. I just plug it in the formula. And then for the square, we have base equals 6 inches, height equals 6 inches. Plug it in the formula. Now the area of the figure, how am I going to get the area of this total figure? Area total equals the area of the triangle plus the area of the square. So I simply add those two together, and the total area is 60 inches squared. Easy enough. We've done those before. It's all about labeling and using your formula. And you have one more problem to do. Pause the video, give it a shot. That was pretty easy. It just said suppose the base lengths are doubled to 12 inches, but the height remains the same. How does it affect the area? Well, that's pretty easy to see. So I just redrew my triangle here. Base times height for the triangle is 48 inches squared. That's double what we had before. And now our rectangle is no longer a square. Base times height gives us 72 inches, and which is double the original. So how come that's doubled? Well, because your area doubles because it's times 2 because you times 2 one of your sides. If we doubled both sides, it would be 4 times because it would be times 2 and times 2 because area is side times side. So if one side is times 2, everything's times 2. If both sides were times 2, it would be times 2 times 2, which would be times 4. So that was fun. This is the first section in this chapter, and it seems like it's going to be really easy. I think you will enjoy doing this homework. Make sure you draw and label and write your formulas. And you know, color makes everything better. Enjoy your homework.